Girl, please with me for a while. Hello. It's a phenomenon of energy transport but without transferring matter. Yes. And this transfer of energy is from where? Where you can get the energy transfer? It's by what? It's by a, see my position. What is it? See my action. What is it? When the wave propagates, how the wave will propagate, how the wave is produced, actually. How a wave is produced. Yes, vibration. Okay, so for the wave, okay, the definition of wave you must talk about, okay, it's a phenomenon of energy transfer without transferring matter by a vibrating system. So in other words, the vibration of the particles will produces the wave, and the wave will transfer the energy from one place to another place. Okay, clear? But without transferring the particles. The particles only vibrate to produce the wave. Okay, and wait, please wait for a while. Stop sharing first. Yeah. Hello. 我现在有课哦，我有 online class 哦。哈，可以。好像是没有，只有阿扎利亚有吧？应该是阿扎利亚有。OK， 好，拜拜。哎，还是关天应该有关天。Yeah, okay, come back here. Okay, right. So then we have learned about. I'm so sorry, girls. I don't know why I cannot see your chat now. Okay, so if you have any questions or if you want to answer my questions, you just unmute yourself and tell me the questions answer lah, huh? Okay. Okay, then we have learned about there is a different type of waves, okay, progressive wave and stationary wave. Okay, stationary wave means that the wave it does not propagate with time. Okay, so the most common example is the vibration produced by musical instruments, for example, guitar, okay, maybe violin, okay. So the wave produced by a musical instrument is a stationary wave. Okay, it's a stationary wave. Okay, then progressive wave, we have transverse wave and longitudinal wave. Okay, later on I will explain further a little bit what is it about. Okay, then not only that, the wave can be separated into mechanical waves and electromagnetic waves. Okay, so these two is depending on whether they need a medium to transfer the energy or not. For mechanical wave, yes, it requires a medium to transfer the energy. And electromagnetic wave, it doesn't need a medium to transfer the energy. Okay, so next we will talk about the difference between transverse wave and longitudinal wave. Okay, transverse wave and longitudinal wave. Okay, so for transverse wave and longitudinal wave, they are different. The difference is based on their vibration of the particles. Okay, vibration of the particles. Okay, so how the particles vibrates will help you to separate it into transverse wave and also longitudinal wave. Okay, so for transverse, hello. All of you, can you please unmute yourself first? I see your chat already. Sorry. Okay,来。You all wait a while. Please wait for a while only. Here come. Okay. Okay, finally I can see the chat already. You all can just write down what you want to ask and what is your answer in the chat box. Okay, I can see your chat already. Okay, so you see these are the two different vibration of the particles. Will help you to separate it into transverse wave and longitudinal wave. So you see the transverse wave. You look at the transverse wave first. The transverse wave, can you see how does the wave is moving? This one is actually simulate how the particles is moved, okay, when it produces the wave. Okay, so the transverse wave, yes, is going up and down, up and down, up and down. So which means that if let's say the particles is over here, the particles, this is one of the particles inside the wave, you will see that as the wave propagates, okay, the energy propagates in front, the particles is moving up and down, up and down, up and down. So if you look at here, the direction of propagation always it will be in a straight line. Okay, then this one, what is the angle here? If let's say according to this one, is moving up and down with the direction of propagation, what is the angle here? Yes, 90 degree. 90 degree, very good. So which means that for transverse wave, the particles, okay, the particles is vibrate, okay, perpendicular, okay, to the direction of propagation of wave. Okay, so this is how is it, huh? Okay, so then for longitudinal wave, again, you see here, okay, how is it this longitudinal wave is the particles is moving? Left and right, yes. So if let's say you imagine this is the one of the particles inside the wave, okay? So, sorry. Okay, so like this. So it's moving left and right, left and right, left and right, left and right as the wave propagates, So if let's say left and right and the direction of this propagates, what do you think it is? How does it move together with the propagation? The top one is moving perpendicular. The vibration is perpendicular to the direction of propagation of wave. How about longitudinal wave? Very good. Like what Pei say, yes, it's parallel. So the particles, okay, particles, if let's say left and right, we will say that it's vibrate, okay, vibrate parallel to the direction of propagation of wave, okay, to the direction of propagation of wave. Okay, so if you look at the first letter of the words transverse wave and longitudinal wave, is also will help you to differentiate, okay, or help you to identify how the particles is vibrating. So T here you can get an angle of 90 degrees. So which means that the particles is vibrate perpendicular to the direction of propagation of wave in a transverse wave. Then for longitudinal, long, so which means that it is parallel to the direction of propagation of wave. Okay, get it? So this is how you differentiate it. It's based on the vibration of the particles. It's based on the vibration of the particles. Okay, so again, so this one is going up and down. You see the particles. You see the spring here. It is not moving in front. It's just that the wave, the energy is moving. Okay, so which is why we say that the particles is vibrating to produce wave, and the wave is transferring the energy. Okay, same goes to here. You see the longitudinal part. The spring is not moving. It's just that the wave is propagating from one part to another part. Okay, so the particles is only vibrating. Yeah, can I? Okay, good. So we have differentiate between transverse wave and longitudinal wave. So the example of transverse wave, it will be water wave and also light wave. Water wave and also light wave. You see here, there is a T here. T stands for transverse. Okay, so this is another way for you to differentiate between transverse wave and also longitudinal wave. So longitudinal wave, the example, it will be sound wave. There's no T, so no T, so it's a longitudinal wave. Okay, can I? No problem, Any problem at the moment? Yes or no? No problem. No, okay, good. Others, can you understand what I'm talking about? I only heard the answer from Emily, Hui Yi, Alicia, and Jimmy. Others, no problem, Okay, Shamira, you can hear me already, now? Okay, good. Okay, so now next part. Next part of this 5.1 is we need to learn five terms. Okay, five terms related to wave. Okay, because with these five terms that we have learned, we need to find the values in thickness. The light wave move in a straight line, right? Then why transverse wave? Okay, any wave also it will move in a straight line, but it's depending on how the particles is vibrating. Okay, for light wave, the particles is vibrating perpendicular to the direction of propagation of wave. That's why we will say that it is a transverse wave. Okay, remember transverse wave and longitudinal wave is differentiate based on their vibration, the particles, how the particles vibrate. Okay, Venus. Okay, good. So we come back to here. Okay, we have five different terms that we need to learn. Okay, because these five different terms we will apply it in a wave diagram, which I will teach you also later. Okay, to find the values. Okay, so before we learn about the five terms, okay, this is a transverse wave. This is how a wave diagram. Yes, correct, Venus. Okay, so this is the wave diagram. Okay, wave diagram. Okay, wave diagram of a transverse wave and also a wave diagram of a longitudinal wave. Okay, as you can see, the particles now is moving up and down, up and down, up and down. So that's why you would, wait, Alicia. How do we know is a successful phase in a longitudinal wave? What do you mean by successful phasing? Because the phase is actually like interval one. You wait now, that's why I want to explain it now. Sabaya. Okay, and follow me, okay, follow me, okay, so here, this is a transverse wave. You see, I need to repeat so many times. Okay, so the particles is moving up and down, up and down, up and down, up and down. That's why you will produce this kind of wave. Okay, this kind of wave. So the upper part we will call it as crest. Lower part we will call it as trough. Okay, so the wave is like moving like a crest to a trough, crest, trough, crest, trough, like that. It's up, down, like that. Okay, can I? Okay, so for longitudinal wave, because the particles is moving left to right, it's parallel. The particles is vibrate parallel to the direction of propagation of wave. So you will have these two how do I say the phase? Okay, this crest and trough we will call it as a phase. Okay, phase. Okay, so for longitudinal wave, it won't have crest and trough, but it will have another two different phase, which is compression and also rarefaction. Compression is where the particles is moving together. Then compression is release. Compression, release, compression, release, like that. Okay, can I? Can follow here at the moment? Still can follow or not? Okay, good. So now we already know the phase of a transverse wave and also a longitudinal wave. You must know how to differentiate the phase because we are using the phase to find one of the terms. Okay, so the five terms that we need to learn, it will be, first one is amplitude. Okay, okay. So this one is notes number 7. Okay, notes number 7. I want you to copy everything inside your notes. Okay, notes number 7. So amplitude. Okay, so this straight line we will call it as equilibrium position. Is where the starting point is. Okay, the starting point is not number 6. I don't know. Just now, Sophia said it's number 6. Number 6. Okay, sorry. This one is number 6. Number 6. Okay, sorry, Sophia. I forgot it. Okay, this one is number 6. Okay, so amplitude. This is amplitude. And amplitude, the symbol of amplitude, it will be small letter A. Okay, small letter a. What is amplitude? Is the maximum displacement from its equilibrium position. So the straight line here is the equilibrium position, and the unit it will be meter or centimeter. Okay. Okay. Next, wavelength. So wavelength here. Okay. So this is the second term that you need to learn. Okay, wavelength. Wavelength is the distance between the 2 points of the same phase in a wave. Okay, 2 points of successive, which means that it's next to it. Okay, next to it. Okay, successive point of the same phase in a wave. Okay, the unit also is measured in meter. Okay, so I give you one example. So if let's say this one is the center part of a crest. Okay, sorry. This one is the center part of the crest. So we will take the successive center part of the crest, and this is one wavelength. Okay, this is one wavelength. Same goes to if let's say it's a trough. Okay, so we take the center part of the trough. So where should it be? It should, if let's say we want to take it as a one wavelength, so it should be on top here or at the bottom here. Top or up or down. Which one should be a wavelength? Based on the definition of wavelength, is the distance between the two successive points of the same phase. Down. Yes, correct. Down. So this is the wavelength. Okay, so another example. Okay, another example. I think I clear everything first. It's very confusing. Okay, so now okay, if let's say I start from here. So which means that is the end part of the trough. Where should I stop? I should stop at this 1 or 2 as one wavelength. One or two as the wavelength. Aina say 2. Wei also 2. Witness also 2. The rest? Okay, I think most of you can get the answer correct. This is 1 wavelength because it's a successive. The successive end part of the trough. Okay, successive end part of the trough. Okay, so if let's say it's a beginning part of the crest, I think over here is the beginning part of the crest. Here also we will consider it as one wavelength. One wavelength. Okay, Jingling can get it, huh? Okay, if you look at this graph, can you tell me how many wavelength is inside? How many complete wavelength is inside? Starting from the first point. How many wavelength is in? Complete. Okay, Emily, Jingling, 3, Alicia also 3, very good. The answer is 3. So because you see, the beginning part of the crest to the next beginning part of the crest, this one is one wavelength. Then this one to the next beginning part of the crest, one wavelength. Here to the beginning part is also considered as one wavelength. Okay, can? This one weakness we not count already because I said my question is complete. Okay, complete. So this one is happened in transverse. If let's say longitudinal wave is also the same thing. So if let's say we take the second line of the compression. So you see the next compression, the second line of it, that will be your one wavelength because it's the successive one already. It's the successive one. Okay, can get it? If let's say we use rarefaction, also can. The center line of the rarefaction, okay, to the successive center line of the rarefaction. So this one is also a wavelength. Okay, and in a wave system or in a diagram, the wavelength it will be the same value. Okay, it will have the same value. Okay, others can get it? No, it's depending on the question. Okay, my diagram here is bolder, that's why it will be seen clearly. Okay, can I? No problem here. Yeah, can I? Okay, so Next, okay, so this will be notes number 7. Okay, notes number 7. Okay, so last week we have learned about wavefront. Wavefront is a line that connects all the face together, all the face in the same direction together. So it will have two types of wavefront. If this will be a plain wavefront, this is a circular wavefront. So if the question give you a wavefront, to find wavelength, this is how you get the wavelength. Okay, is the successive. So you see, this is one wavefront. The successive wavefront between this is the distance, it will be your wavelength. Okay, get it? Can follow here? Can follow here or not, everyone? Yeah, yes, can Okay, now, just now I said we got 5 terms we need to learn. We have learned about amplitude already. We have learned about wavelength already. Okay, now I give you one example here. Okay, so the question sometimes they will give you like this. They will give you this is the length of the 10 cm. Then what is the amplitude? So you must know that where is your amplitude start. Okay, so you can draw like is an equilibrium, a line as an equilibrium position. So your amplitude is the maximum displacement from the equilibrium position. So the answer, since here is 10 cm, actually it is considered as 2 amplitude here already. So you divide by 2, it will be 5 cm. Okay, can I? No problem here. Okay. Okay, good. Okay, next. Okay, for this example, is based on the wavelength. So what is the value of a wavelength when they give you this 15 cm? So you must know how to identify the wavelength, one wavelength. So you remember the definition of wavelength is the distance between the two successive points on the same phase. Two successive points on the same phase. So can you tell me what is this? Is a compression or a rarefaction? Compression. Emily says compression. Others agree or not? Okay, good. It's a compression. So we must start to see, okay, from the center part of the compression to the successive center part of the compression. This one is one wavelength. Then next, another wavelength. Then next, another wavelength. So within this 15 cm, you will have 3 wavelengths inside. So the value of one wavelength, what you need to do is you just 15 divide by 3, then you get the answer is 5 cm. Very good, yes. Emily, divide by 3. Okay, so this is how you get solve this kind of question. Okay, sometimes, usually they will give you this kind of question. Okay, clear, everyone? Any problem here at the moment? Okay, no problem, Okay, good. Lambda, yes, it's a lambda. Okay, so now we will learn another 3 terms. It will be period, frequency, and wave speed. Period, frequency, and also wave speed. This one I will explain to you using a whiteboard. So you wait me a while. Okay. So, so this is a transverse wave diagram. Okay. Sorry, my drawing really not good at all. Okay. Yes, the symbol is lambda. I want to draw a nicer one. Not nice. Never mind. Okay. Up, down, up, down, up, down, up, down. Okay, so this one is time, second, and this is the length. Okay, length, displacement, okay, meter. Okay, so we refresh a little bit. Okay, what is the amplitude here? Thank you. 5 meter. Very good. It's 5 meter. Okay, so refresh back already lah. Okay, on this part we cannot find wavelength. Later I will tell you why we cannot find the wavelength here. Okay, so now I will focus on period, okay, frequency, and also wave speed. So this is another 3 terms that we need to learn. Okay, another 3 terms that we need to learn. So for period is the time taken for one complete oscillation. Okay, time taken for one complete oscillation. So wait, 0.25. This one is 0.5. This one is 0.75, and this one is 1.00. Okay, so in this wave, how are you going to consider as one complete oscillation? So as I said just now, the wave is like alternating between a crest and trough, crest and trough, crest and trough, crest and trough, or compression, rarefaction, compression, rarefaction. So the crest, one crest and one trough, we will consider it as one complete oscillation. Okay, one complete oscillation. Okay. Yes, and one S shape is one complete oscillation. So if let's say you look at here, this is one complete oscillation, and this another complete oscillation. Then this the third complete oscillation, and the here is fourth complete oscillation. So for period is time taken for one complete oscillation. So based on the drawing, can you tell me what is the value of the period? What is the value of period? Yes, Shamira, is total 4 complete oscillation over here. Correct, 0.25 seconds. So because here, as I said here, is one complete oscillation. One crest and one trough is one complete oscillation. Okay, one complete oscillation. Okay, so this is period. Okay, period and frequency is actually interrelated. So frequency, okay, frequency, okay, frequency is the number of complete oscillation in 1 second. Okay, number of complete oscillation in 1 second. Okay, number of complete oscillation in 1 second. So in order to find frequency, frequency is the symbol of frequency. Okay, sorry, the symbol of period is T. The symbol of frequency is F. Okay, and the symbol of wave speed, it will be V. Okay, yeah, okay. Like this, so never mind, you go out first, we come back again. Okay, Ken? You go out, come back. Okay, so see you later.